Agricultural productivity, the efficiency with which we turn resources into food, is essential for feeding the world. As the population grows, so does the demand for efficient farming. That's where Meg Miller, a veterinary technician and agricultural professional, comes in. She's dedicated to improving yields and efficiency. But there are challenges. Climate change disrupts traditional practices, reduces yields, and makes crops more vulnerable. Land degradation and water scarcity make it even harder to grow enough food. On top of that, farmers face rising costs, uncertain markets, and limited access to credit and new technologies. Sustainable agriculture is a holistic approach that balances environmental health, economic profitability, and social equity. It minimizes the negative impacts of farming on the environment and promotes long-term resilience. Farmers use techniques that reduce reliance on external inputs and foster biodiversity. This not only helps the environment but also improves overall productivity. Meg Miller says sustainable practices benefit the land. It minimizes erosion, preserves soil structure, and promotes organic matter, which helps retain water and nutrients. Sustainable farming also helps mitigate climate change. Practices like agroforestry and cover cropping capture carbon from the atmosphere. Additionally, by promoting biodiversity, sustainable farming reduces reliance on chemical pesticides. Economically, sustainable farming can be more profitable. While there may be initial investments, the long-term benefits like reduced input costs and resilience to climate variations make it a stable and viable system. Crop rotation is a key practice. Planting different crops in sequence disrupts pest and disease cycles, improves soil fertility, and reduces the need for chemicals. By diversifying crops, farmers can optimize nutrient use and minimize the risk of soil-borne pathogens. Conservation tillage techniques, like no-till or reduced tillage, disturb the soil as little as possible during planting. This helps retain soil structure, prevent erosion, and conserve moisture. It's not only environmentally friendly but also reduces fuel consumption and labor costs. Integrated Pest Management (IPM) combines biological, cultural, and mechanical methods to manage pests. By using natural predators, crop rotation, and resistant crop varieties, farmers can minimize chemical pesticides. IPM reduces environmental impacts and maintains the balance of ecosystems. Technology is transforming agriculture. Precision farming uses sophisticated technologies to optimize resource use, improve efficiency, and make informed decisions based on real-time data. Global Positioning System (GPS) technology is a cornerstone of precision farming. Farmers can precisely map their fields, enabling accurate management of resources. GPS-guided tractors ensure precise planting, harvesting, and application of inputs, reducing overlap and waste. This not only increases efficiency but also reduces fuel consumption and environmental impact. Remote sensing technologies like drones and satellite imagery provide a bird's-eye view of fields. Meg Miller says, these tools enable monitoring crop health, identifying pest infestations, and assessing overall field conditions. By analyzing this data, farmers can make timely interventions and optimize crop management strategies. Remote sensing helps conserve resources and ultimately bolsters productivity. Water scarcity is a major challenge, and smart irrigation systems are a beacon of hope. These systems use sensors and data analytics to assess soil moisture, weather conditions, and crop water requirements. By automating irrigation, farmers ensure crops receive the precise amount of water they need, reducing waste and enhancing water use efficiency. This preserves a precious resource and improves crop yields and resilience. Farm automation with technologies like autonomous harvesters and robotic pickers streamlines the harvesting process, reducing reliance on manual labor. Automated machinery operates tirelessly, ensuring a faster and more efficient harvest, crucial for meeting the demands of a growing population. Marrying precision farming with automation ushers in a new era of agriculture. The soil, teeming with microorganisms, is fundamental to plant life. Recognizing the complex interactions within the soil is crucial for ensuring its long-term fertility. Soil health goes beyond mere fertility. It encompasses physical, chemical, and biological aspects. A healthy soil structure facilitates water retention, prevents erosion, and promotes root development. The chemical composition influences nutrient availability, impacting plant growth and resilience. The biological component, with its diverse organisms, contributes to nutrient cycling and pest regulation. Soil analyses provide insights into nutrient composition. Armed with this knowledge, farmers can tailor nutrient management to meet the specific needs of their crops, avoiding deficiencies and excesses. Nutrient management involves applying fertilizers judiciously based on soil test results and crop requirements. This precision optimizes resource use and mitigates the risk of nutrient runoff, a major contributor to water pollution. Cover crops, planted between cash crops, protect the soil, suppress weeds, and enhance organic matter content, fostering a healthy environment for beneficial organisms. Crop residue management involves thoughtfully handling leftover plant material after harvest. Retaining crop residues on the field contributes to soil health. The relationship between cover crops and residue management extends beyond soil health. It also reduces the need for chemical interventions and enhances soil structure. Soil health management is a multifaceted strategy that encompasses testing, targeted nutrient application, cover cropping, and residue management. Knowledge transfer programs disseminate advancements, best practices, and techniques to farmers. Workshops, seminars, and demonstration can all be effective ways to introduce farmers to new ideas. However, knowledge transfer needs to be a two-way street. Following these initial sessions, successful programs often incorporate farmer-to-farmer learning. This can involve creating groups where experienced farmers share their knowledge with beginners, or organizing field visits where farmers can see new techniques being applied in real-world settings. Mentorship programs. Pairing experienced farmers with new ones can provide ongoing support and guidance. On-farm trials. This allows farmers to experiment with new practices on a small scale before adopting them more widely. Use of technology, mobile apps, online platforms, and even SMS messaging can be used to share information, answer questions, and provide ongoing support to farmers. By combining these elements, knowledge transfer programs can ensure that new advancements, best practices, and techniques are not only introduced to farmers, but also effectively adopted and adapted for their specific needs and contexts.